When the Second World War started in 1939, the RAF's Bomber Command was equipped with three main types that were, technically speaking, their heavy bombers. The Handley-Page-Hampton, the Armstrong-Whitworth-Whitley, and the Vickers Wellington. And of these aircraft, the Wellington was to prove the most useful. Solid and dependable, the Wellington would be the most produced British bomber of the entire war, being built from 1936 until 1945, and used in a multitude of different roles. But even before the outbreak of the conflict, the RAF were thinking that these designs would soon need replacing with larger aircraft that could carry even greater bomb loads over bigger distances. And to accomplish that, these new aircraft would need far more engine power. Initially, plans revolved around twin-engine designs, typified by the Avro Manchester and the Vickers Warwick. But though these did get into service, they experienced problems with their power plants and were also recognised in the light of combat experience as not really meeting the RAF's growing needs, and so four-engined heavy bombers became the standard for the service. But even if these were just getting into the squadrons, the British authorities wanted design work to start on their replacement, because if there was one lesson being demonstrated during the war, it was just how quickly technology was moving. Hence why the Wellington went rapidly from being considered a heavyweight to a medium bomber. So even as the Lancaster and Halifax heavy bombers began to enter service in the early 1940s, the British were thinking about their replacement. And while the Wellington was still in full production and highly valued, it was no longer in the premier category. And so in 1941, Vickers set about developing a new heavy bomber for the Royal Air Force. This would take shape as the Vickers Windsor. Initially, this was intended to fulfill a specification for a high-altitude bomber, which essentially took the existing Warwick and fitted it with a new wing with four engines. A development path that would have mimicked that of the Avro Manchester and Lancaster. But with the Air Ministry issuing a specification in 1942 for a future replacement for the Stirling, Lancaster and Halifax, Vickers decided to take the work they had done on the new wing and created a fresh fuselage to maximise the aircraft's potential. This was initially required to carry a bomb load of 8,000 pounds and be capable of 350 miles per hour at an altitude of 31,000 feet. Two prototypes were initially ordered, followed by orders for additional prototypes, pre-production aircraft, and in April 1943 for 300 production Windsor B Mark 1s. In design terms, the Windsor used the techniques already employed by Vickers. Their line of bomber aircraft, originating with the Wellesley in 1935, were designed by the genius of Barnes Wallis, he of bouncing bomb fame. Wallis had pioneered the geodesic airframe as the construction method for Vickers bombers. This contrasted with most aircraft construction techniques in that instead of using beams to build the airframe and aircraft skin around, a geodesic design used a lattice framework of light alloy to create the structure, removing the need for internal beams as the outer basket weave provides the aircraft with its rigidity. This lightens the structure and frees up internal space, as well as providing great strength and tremendous resilience to damage. The Windsor used the same geodesic methods, including on its huge elliptical wing, which had a span of 177 feet and 2 inches. This was effectively hollow from tip to tip, and in the production machines was intended to hold the main tanks, which were expected to carry 16,275 litres of fuel. However, the geodesic design didn't really lend itself to the use of metal skin on an aircraft, and Vickers' earlier bombers were skinned in doped linen. This wasn't considered suitable for the higher speeds expected of the Windsor. The problem for Vickers was that they were geared for geodesic construction, and switching to other construction methods would entail a major disruption to their production capability while they retooled and retrained their staff. So they applied some ingenuity and developed a new flexible skin made of extremely thin steel wires and ribbon woven into a cloth and then doped with PVC. This provided an extremely strong skin construction that could withstand the pressures expected of it, but it was not a simple construction method, apparently requiring the use of a tuning fork to get the stressing correct on application. But such flexibility and strength was required because the Windsor's wing construction, not using rigid spars for support, required special thinking and adaptation. Wallace therefore designed the outer wings to take up the pressure from the gross weight load by rising after takeoff, with the wingtips lifting by more than 4 feet as the plane left the ground. This apparently took some getting used to by the pilots who did fly the Windsor. To compensate for this wide-track loading when on the ground, the Windsor also employed an unusual undercarriage, with each engine nacelle being fitted with a retracting wheel. This did make for a better load distribution, though the pilot did have to be aware of the outer wheels so as to not catch them on anything or run anything over. The Windsor's body was also surprisingly bulky, with very little ground clearance. This was due to the recognition that the initial 8,000 pound payload specification was too light a load, especially compared to the bomb loads being carried by the aircraft the Windsor was planning to replace, and as a result extra capacity was designed in. This is an important consideration as regards to geodesic designs, as they do not have the ability to undergo major structural changes in contrast to more conventional construction techniques, because of the interwoven nature of their structure. As a result, the bulk of the Windsor was expected to provide it with a maximum bomb load of 12,000 pounds. On top of the bomb payload, the defensive armament was somewhat unconventional, being composed of 2 forward-firing 303 machine guns in the nose, and 2 barbettes in the rear of the outermost engine nacelles. These would each contain 2 20mm cannon and be directed by the rear gunner, who had a position in the aircraft's tail. As it was, this was only fitted in the third, and as it turned out, final, prototype. First flight was conducted in October 1943, with this aircraft being fitted with a power plant of 4 Rolls-Royce Merlin 65 engines that produced 1,315 horsepower each. These were replaced in the next 2 prototypes by Merlin 85s that produced 1,635 horsepower each. The Windsor reportedly flew extremely well, being very responsive for such a big aircraft and having surprisingly few issues. Top speed achieved was 317 miles per hour, which, while not as fast as initially specified, was an improvement over the current generation of heavy bombers. Indeed, compared to the Lincoln 1 that was in development at the time for the same requirement, the Windsor was faster and had a longer range with a 12,000 pound bomb load. A setback was experienced when the first prototype was lost in a landing accident in March 1944 during testing, an incident that notably broke the aircraft but left the crew unharmed. But such losses are entirely expected, and the second and improved prototype was already conducting flights by that point. In fact, concerns weren't really with the aircraft's performance, but mainly in its single pilot cockpit. This, located high up in the aircraft, gave excellent visibility, but there were issues that the position was difficult to access in case the pilot was incapacitated. Consideration was then given to fit in a more conventional nose layout closer to existing designs, as it was plain by now that the Windsor wouldn't be seeing action over Germany, but in the Pacific. Here its huge wing capacity raised the prospect of creating a very long-range bomber, and Vickers proposed a version that would carry a 4,000 pound payload with a range of 4,000 miles. Production was expected to get underway in 1945, and the aircraft's increasing weight led to consideration being given to fitting it with more powerful Griffons and even the new Clyde turboprops that were in development to further boost performance. But as it was, these all stayed on the drawing board. In late 1944, the order for 300 was cut to 100. Issues with the complicated barbette gun positions were causing concern, and the Lincoln, a far simpler design in comparison, was proving much more straightforward in its testing. With the end of the war in September 1945, there was no need for 2 main heavy bomber types, and in November of that year, the Windsor orders were completely cancelled, with the first of the pre-production aircraft in an advanced state of construction. By 1946, the 2 remaining prototypes were relegated to ground instruction duties and would be scrapped shortly thereafter. Thus ended the Windsor, the final bomber in a line started by Barn Wallace in 1935. Because when Vickers built their next bomber just a few years later, the Valiant, it was of a thoroughly modern design. And if you want to know more about that aircraft, check out the videos coming up now.